Good afternoon. My name is Sufi Safavi. I'm the Director of Applied AI at Black Knight, and I have the privilege to be here to share some of our experiences that we had recently and kind of throughout my career. To introduce myself, I thought to actually give you guys a little story of how I started. So when I graduated from college, enamored with space, and my goal was to become space scientist. And my first success was I got the job, and the company that I was working for, we were actually building parts for the Challenger. So told everyone, I said, guys, wait, I'm gonna make it. Then when actually I started, I said, so which parts of the Challenger we are building? And they said the door latches. I said, okay, I can handle that. That's not, I thought the engine or the combustion, and we're gonna get into actually some of this stuff. So that was my first kind of reality check and hit. Then started building. I actually ended up building a lot of simulation for actually stress testing of the door latches, and good results, great results. Then little by little understood how actually basically the space game works, because it's very critical. When they build a product, they build 3 versions of it with 3 different companies, and you finish it and they pick one. So the second hit and the reality check was the part that we built never made it to actually any spaceship. So that was kind of the second. And the last part was when I got let go because there was nothing else to do, I ended up joining the mortgage industry, which I think that was, ultimately all the dreams of going to space just went away. So today, I got a good news and a bad news for you guys. One is we're going to talk about a very, very hot topic, machine learning and AI. The bad news is we're going to talk about that in the mortgage industry. So bear with me. I'll try to actually make it interesting, and hopefully there are actually some takeaway for you guys. So what we're going to do today, we're going to kind of take you through a journey of how we leverage actually AWS, how we started with pretty poor results, and going to talk about it. But we kind of held on set of principles that ultimately help us to be able to get amazing results. And we're going to kind of share every single one of those stories and actually kind of principles. And at the end, we're going to open that up for actually any questions that you guys have. So mortgage industry. What did I do? All right. Mortgage industry. Mortgage is nothing other than a contract that is actually signed between a lender and a borrower to basically lend them some money. And typically, there are around 10 to 15 million of those contracts every year is being actually created. So it's not an innovative process. It's just creating that actually contract. But this industry, ultimately one of the biggest fuel of the GDP. If you look at actually ultimately industries like manufacturing, which basically this is every single piece of goods that is built in United States, is the size of the housing industry that we have, around 13% of US GDP. And at this point, the mortgage debt in United States is up to $15 trillion. So it's a pretty serious actually contributor to the GDP, and ultimately some of the impact of that we all actually heard or felt during the 2007-2008 meltdown. So it's an industry that is actually, it's very important, but has gone through a lot of actually kind of negative, and I would call it kind of backwards evolution. If you look at every single industry in the last 10 years, they have over double-digit productivity gains. Things are faster, things are cheaper. We had the exact opposite of that in our industry. To create a mortgage back in 2007, it would cost around $2,500. 2017, and that number is continue going up to 2019, is $8,000. And this is the cost of origination, and it does not really include what borrower at the end of the day they pay to be able to get into that house. So for that contract that I talked about, which happens 15, 10 million times a year, we are creating that contract for the cost of $25,000. But why is that? Why such an enormous number for something that is, ultimately so simple? And it takes that long to be able to do that, and that many people participate in that. To close a loan, there are active 20 participants in that process. As a processor, as an underwriter, as an escrow agent, as a loan officer. One of the things that actually we always talk about is we don't have the parallel and equivalent in other industries. If you look at aerospace, 20 people, 40 to 60 days, but a flight from New York to Mumbai, 16 hours, and only 7 minutes, the pilot is in charge. And building this 700-page contract, which is 10 million times a year we are actually repeating it, it's going to cost us that much, and we have that level of participation. So the root cause is actually in kind of 3 areas. But more importantly is actually go back to the history of this industry. If you guys go to the medieval times and Renaissance, banker was a person, had a lot of money, would sit in the market and would lend money and get money and so on and so forth. So the entire profession and industry started with human as the main actor. If you look at aerospace, as an example, when the Wright brothers, they connect themselves to that wooden structure, they put their faith in the technology. And as a result of that, decades later, it takes 7 minutes of human participation to be able to actually fly an airplane. So there's historic aspect of this, but there's some of this stuff that is ultimately basically something that we created. So if you look at what is the biggest contributor to this cost structure that we talked about, all of it, majority of it, is human labor because of that human-centric process that we have. But why humans, they actually continue being the main actor in that process is because of distrust in data. And as a result of that, humans are the only last hope to be able to actually verify and attest that this actually data is good. So let's use a couple of examples. A decade ago, we actually built models called AVM, the automated valuation models, to be able to calculate a price of a home based on what's going on in the market, what's happening in the recent sale that we have. But never became the de facto mechanism to actually evaluate a property. You still need someone to go to the property, called the appraisal, and look at this stuff to make sure that actually everything is in order. And if you are a very forward-looking organization, you actually do this thing called drive-by, which is you don't have to go inside the house. You still send a human to look. There is no hole. There is no major construction. The roof is still there. So the distrust in that actually information is costing $400 to $500 per actually transaction to be able to do this appraisal. If you go to the other aspect of actually financing a home is evaluation of credit risk, which the borrower, how risky it is, the individual is. We have a trusted source for that data, which is the credit report. You know, as much as we can actually debate is the FICO score is a good representative or not, but it's a trusted source of information. And the lender, they spend $2 to $4 to pull the borrower credit report and make a judgment that this individual has the ability to pay or not. $500, not a trusted source of information. $4, trusted source of information. The other aspect of these action inefficiencies is rooted in some of the redundancy that exists in the ecosystem. And some of those redundancies due to actually the federated model that we have with our government and actually the justice system. So for us to be able to claim the ownership of our property and go through a foreclosure process, you go to a court at the end of the day. And the judge needs to actually basically order to get out of the house if you haven't paid for it. Our court system is not accepting an immutable ledger. Our the court system is not going to actually look at a JSON file to just say, okay, the data is there. They look at papers. And as a result of that, this industry needs to produce and consume papers. And the movement of this paper through the ecosystem, it's actually create the biggest cost of operation. During the life of a loan, 7 times the ownership and actually the participation changes. The lender lends, the servicer services, the mortgage insurance company put an insurance on that, the BPO provider that does the QC, the investor invests, the combat servicer process some of the actually troubled assets that they're there 7 times. And this representation of loan, which is a 700-page document, every time changes hand, require these participants to go, at a minimum, figure out what's in the 700-page document. And to this day, they haven't been an effective way to do that other than human. So the human, they look at it. First, they rack and stack that to just say the first pages, 3 pages is the 1003. The 4 pages is actually your bank statement. This one is your W-2. That simple classification of this actually document cost this industry $2.5 billion a year due to some of these actually inefficiencies that we talked about. So today, we're going to talk about a worker bot that we have created that ultimately is intended to create a workforce arbitrage to be able to delegate some of these activities, which probably not in the foreseeable future, it's going to be actually eliminated. And some of the lesson learned in building that platform on AWS. But before we get into some of the technical aspect of this platform, the intent of this platform was to do multiple things. And if we could not do these things, at the best, there was no reason for it to exist. If the machine could not do the same thing, in this case, classification of document, at a fraction of cost of a human, there's no reason for that to exist. Well, the humans, they're doing a better job, they are there. So the significant exponential cost reduction in that operation, a must. It should have focused on the repetitive processes, because to be able to shave off big numbers out of this billions of dollars that the industry is actually spending to manufacture loan, it should focus on the things that they're labor intensive. And it requires cognition, but it's actually repetitive. It should be able to actually learn, because the example that I used in terms of classification, it was a sliver of the supply chain manufacturing process that we talked about. So it should be able to learn the first step, and then another skill to be able to do another thing and another thing, to at least get to the point that all the repetitive activities can be fulfilled with the skills that this worker bot has. Be able to learn new skills in days, competitive to humans, that's what we do. Sometimes depends on, I learn things a little bit slower, so that's a different story. And be able to actually have an OpEx model, because that's how human labor works. You don't buy a license to a person to just say upfront you pay $1 million and then we just pay maintenance fee on this individual. You actually pay them based on a salary, based on a rate, based on the work that they do. So this worker bot, it should actually have the same elements as a human worker. But complicated things, probably none of these concept, except the reduction of cost, has been achieved by any actually technology, at least in the domain that we exist. So for a computer to be able to achieve those goals, there should be a series of capabilities that ultimately is required to achieve them. That worker bot, that computer, needs to read business content as good as human. Be able to comprehend that content as well as human. Be able to arrive at conclusion the same way human arrive at the conclusion. Be able to remember things and be able to actually learn things. One of the advantages that we have as human over the computer, especially some of the algorithms that ultimately beyond their training they don't have memory. You've seen many times we actually get a piece of information, a document, and we take that document and we just kind of do this with our eyes. We are not adjusting our eyesight. You can't do that at will, just adjust itself. What you're doing, you go to parts of your brain that you have memory of similar things. So if you see a bank logo that has a high error and is not clear, is not that actually you see it better, you recall information that you had. So for a computer to be able to be as effective as human, it should be able to recall the information. So, not trivial things. Build things that they can read. They've been decades of studying natural language processing, and now we can effectively read natural language text, but business grammar is a totally different animal. Business grammar has a lot more ambiguity. Business grammar, it has a lot more variability than actually natural language. If you want to look at the English grammar, you can go get a book and it's clearly talk about 95% of the grammar rules that you have. If I tell you where is the grammar of the mortgage industry, there's no such a thing. There are pockets of information. So it's a hard thing to actually to achieve. And to be able to arrive at the conclusions that we talked about, it needs to become really, really, really good at what's the raw material of that industry. Which, as much as we want to say the raw material of this industry is data, it is not. Or the documents. So Ava, which is the name of actually this worker bot that we have created, it should be able to receive information from the loan officer, be able to apply whatever skills that she needs to apply, be able to produce data that now it's consumable with the traditional systems, because, well, we have them, they're rule engines, they're system of records that they're in place, but the reason they're not effective is they need a human operator to actually put stuff in it. And if Ava is doing that, and put the information, then you enable the system based on the deterministic rules that they're in there to be able to do whatever they're intended to do. And you need to actually change, ultimately, the role of a human in that process from the doer of the task to the reviewer of actually the robot. And as a result of that, you'll be able to actually get some of the scalability and the efficiency that we talked about. But to do that, what are the architectural principles? And some of these we're going to actually dig a little bit deeper, needs to be in place to be able to achieve that. So to be able to get those savings, we cannot process a transaction that represents actually a task, potentially, unless it costs us a fraction of a penny. Otherwise, this labor arbitrage, the economics of that is not going to work. Similar to human, whatever this platform that we are building, it needs to learn centrally, but execute based on the differences that actually these participants that they have. If you look at a human, when you go through your career as an underwriter, you learn the art or the science, depends on who you talk to, of the underwriting. And you have that experience. You can work for bank A and be very effective. You can go to bank B. Your knowledge is still the same. You understand the delta that you have in the new organization. You still can become an effective underwriter. So the same concept, the same principle needs to apply to AVA. That not only AVA can actually learn centrally, but at the same time needs to be sensitive with the style and the lexicon and the grammar differences that organizations that they have. It should be able to work both in the back office and the front office, which means it can't be slow. Just put it in plain English. It needs to be fast and needs to actually work uninterrupted as she evolves through different the cognitive maturity he has. Still be able to operate as a junior underwriter while she's learning to become a senior underwriter, and we should not be able to actually create business interruption to do that. Very, very complicated principles to achieve. And I think the founder of Twitter said once, is if you build your MVP and you're not ashamed of it, you build too much. So we did not build too much. Every single principle that we put forward, we failed. A fraction of penny, each transaction cost us over $10. Not going to work. Be able to actually evolve and learn the same way humans actually learning, it would take us 2 weeks to make any deployment into this platform. Having a scalability to create efficiency, we could not get more than 100,000 pages a month from a capacity perspective for customer. This thing would blow up left and right. And in terms of the speed, it would take AVA to do a simple task of classifying information in 20 minutes. Human does that in milliseconds. It was 20 minutes. Wasn't a great start, but ultimately we knew there were principles that we have to hold on to and kind of iterate. And one of the fundamental contributor to that was our inability to actually scale. So if you look at AVA skills, ability to order tax transcript, order and review asset, compile a loan, every single building block that it was contributing to that, it was nothing more than a series of microservices that either it was running an algorithm that it was trained, or it was actually performing any other activity. And where we had majority of our scalability issues was where either our organization, which was actually not a big mature organization as a startup, be in charge of actually managing that infrastructure, or we had ultimately architectural flaws in the platform that we have. The two most contributor that I don't want to actually start a religious war here is we were running servers and we had databases, which actually after those experiences has become a curse word at that organization. Databases, SQL Server, or actually the SQL databases is a bad thing, and the server became the bad thing. But we're going to talk about this evolution. So we leverage a lot of technologies at that point on Amazon, but we either glue them together in an inefficient way, or we actually had them managed with not right principle. So if you look at the entire process, to be able to get a 700-page document classified, you're looking at maybe around 100 to 200 microservices do things from receiving these 700 pages, break them down into the pieces, do an optical character recognition of the content, run algorithms to denoise the OCR data, because that OCR, it doesn't perform well, especially when the quality of the document is bad. do a natural language processing to be able to actually add tag to the content, figure out what are the numbers, what are the dates, what are the actually currencies, what are the institutions, then go through deep learning algorithms to be able to classify that data, then go through additional deep learning actually algorithms to be able to create conclusion off of that, and be able to orchestrate that. We would leverage SWF, which wasn't actually at that time, or at least not the evolution of that into a step function, was a managed basically services. And these algorithms, they're all running on actually EC2s, that we would get bursts of transaction and they would not scale. So at the end of the day, if you get a 700-page document, typically they're around 1,000 words on each page. So 700 times 1,000, you have 700,000 words that you need to push through this process, and in a fraction of seconds figure out what's inside of it. Very complex process, and it was a very bursty process because every package would come in, it would result in millions of actually ultimately objects go through the system. And if you get any type of actually parallelism from a customer perspective, and you will receive thousands of these actually 700-page documents, you would come to a screeching halt. For the remember function or work pattern, we used Elasticsearch, which was a very effective actually mechanism of recalling. Very effective. But if we wanted to remember everything to the words, to the metadata for the words we just talked about, you would get 1,000 transactions times 700 pages times 1,000. So all of a sudden, we had to actually index millions and millions of actually objects on an hourly basis. The infrastructure that we put in place could not handle that. We had sleepless nights to be able to get these transactions through the process and get it in the hands of the customer. It wasn't fun at all. Wasn't fun at all. But there were certain principles that actually we kind of held on to that ultimately kept us alive. The principle number one, it was ultimately, as much as we can, be able to actually go up the abstraction layer. If we don't have to manage it, great. There's no reason to do that. So we started looking at actually serverless at that point and put some of these principles in place. In addition to that, some of the actually flaws that we had from a data perspective. So we talked about the concept of remembering and recalling, but at the same time, the asset that Ava had to be able to train and retrain itself was the data. So we need to get a lot of insight in terms of actually the data and how the data is coming together. If we had a transaction that ultimately the operator would give a feedback, we needed to actually get into their head to figure out why they gave that feedback. If they said Ava was wrong to extract the closing date from a document, Ava was wrong that actually did not read it correctly, which you had a formatting issue in terms of the date. Ava did not correctly tag the date entity, or Ava misclassified a correctly read entity. Those three pieces of information, they have totally different learning value. And without getting insight into millions of objects that they would actually create that data set, there was no way for us to be able to make any judgment call to be able to retrain the platform effectively. So we leverage S3, we pump this data into Redshift, while we were looking for raising money, and our cost of actually storage in Redshift is skyrocketing, all kinds of problems. We went from that to a more serverless structure. we replaced SWF with step function. We went from Elasticsearch that we were managing to the Elasticsearch that is the Amazon Elasticsearch. We went from running our Jenkins servers to actually leveraging the DevOps capability on Amazon. We went from leveraging Redshift, we leveraged Glue and SageMaker to be able to actually shape the data while it was in transit. One of the most complex or the biggest contributor in data analytics is to change the shape of your data. And when data is persistent, it requires the highest amount of computation to actually bring it back up and reshape it. So by the time the data was persisted in S3, for us to be able to analyze it, this millions and millions of objects a day, we had to read it from the S3, reshape it, put it into a dynamo. We moved away from that. As the data coming in, leveraging Kinesis, we actually changed the shape of the data. We distributed to whoever from a microservices required to actually stream that data and understand it. And as a result of that, we eliminated the need for Redshift. We started having the data that it was actually persisted correctly, and we had significant improvement into the numbers. So we went from $11 to the fraction of penny to run these transactions. We went from 2 weeks of deployment to 8, 9, 10 deployments a day. We went from capacity that it was limited to 100K to 1 million, and that million is due to the soft limits. So the system can actually scale. And we would be able to actually do those things in 3 seconds that it used to take 20 minutes. So what made this transition earlier? So now we get a little bit of a kind of technical stuff. Every single microservice that we build carry its own knapsack. There are, in serverless, there are horizontal technologies that you can leverage. And in our opinion, the mistake that we did not make that helped us, we basically did it vertically. That would allow us to be able to treat these microservices totally independent from the point that registered they're actually the name, to how the API gateway was configured, how the Lambda was actually deployed, what the services that it was actually needed, ultimately what the persistent layer, it was in one cloud formation. That independent from the universe, it would operate and would carry everything that it needed. And that allow us very quickly start swapping these actually services without impacting and having major consequences from an architectural point of view. The second thing that it's actually helped us, we religiously manage everything as a code. Everything. There is no configuration. There is no data for testing. There is no infrastructure scripts. Everything is a code. So if you look at every single microservice and you look at the Git repo for that microservice, it has its cloud formation. It has its tests. It has the data that it needs to do the test. It has the code that it's actually performed, and it has configuration that it needs to be able to actually do that. Everything was in Git. So if the world would end, and if we were not to create Ava from scratch, we needed S3 and we needed Git. And in a matter of minutes, we can recreate the entire actually platform. And our platform has a level of complexity due to the security demand that we have chosen for every single customer that they hire Ava to be able to run them in a separate actually AWS account. So in that case, we don't have to solve the data segregation issues, all of that. We just refer to Amazon, an Amazon certification. So as a result of that, anytime there's something changes, hundreds of actually AWS accounts in a minute they need to be updated to get the new version that you have. So there's a massive orchestration that needs to happen. And because everything was packaged in these units of actually computation, it really, really helped us to be able to kind of move pretty quickly and change from a very inefficient actually architecture to something that started achieving our goals. We touched on that. Databases. I can't stop telling you how bad they are. SQL databases. Don't have them. Don't need them. The entire data set that exists for Ava, there are objects in the object store and the metadata that is in Dynamo. Everything. We have caching mechanism. We have actually other means to be able to facilitate the speed if it's needed, but databases slow you down. Obviously, there are certain use cases for them, but again, in our case, we don't need it. We talked about the managed services. This major, major throughput and actually scaling issue that we had with SWF with worker nodes and actually the other tuning that we had to do disappeared when we moved to the step functions. Disappeared. You don't have to worry about how many worker nodes that we have, how do we actually engage some of these tuning, how do you auto-scale, how do you auto-scale actually a workflow when you have in-flight transition, how do you actually figure out, you can reduce all kinds of complexity. It just disappeared when we actually went to step functions. The other principle that we actually learned from Amazon, but we religiously followed, is this notion of bring your own service, BYOS, which means your architecture has to be built in a way that tomorrow if you want to replace with a service that is someone else is providing that, you should be able to incorporate it. And that's a big test for the independence that actually you would try to get in your architecture. And the other piece that it was extremely important is in the microservices paradigm that we had layers and layers of algorithms that they were running as binaries. We didn't get overwhelmed by the sheer number of actually these services that we have. Because ultimately, we build the ontology that while there are services, logically we can actually group them together. We can easily see what are the services contribute to read, what are the component that is needed to be able to read, and what are the microservices associated to that. A very important principle that ultimately, above and beyond what we use, very quickly we made cost as an acceptance criteria. The function of IT finances, technology finances, is an after the fact. Only in software engineering. When a mechanical engineer is tasked to build something, it doesn't show up. It said, build it, it performs, but it's going to cost you $1 million, put it into the car. No, they get a budget for it. They get a weight scale for it. When there's a battery is made for iPhone, you get an allocation, cost, space. The same needs to apply to the technology, to the microservices. At the end of the day, if you want to maintain your cost at a fraction of penny, there is an allocation for every single one of these services. And that allocation needs to be part of your test-driven development. If you build a service that requires a certain capacity from Lambda memory perspective, it has a high I/O in and out from Dynamo. And as a result of that, it's going to actually cost you 2 cents per transaction. It's going to screw up that entire actually balance that we talked about. So bring those into the engineering practices. Make it part of the acceptance criteria. Your release train should fail if you build a microservice that does not produce the result at the cost capacity that you have allocated. Very important, very different engineering paradigm. So every single engineer that we have ultimately manages its own finance. There was no surprises that after the fact do a cost allocation, figure out how much it cost us. We exactly know what's the contribution of every service, and it's worth it to actually kind of swap the cost for quality or speed or anything that we have. It's a cautious decision. Other practices that has actually helped us was measuring, measuring, measuring. If you do not measure, whatever you've done, it doesn't exist. Doesn't exist. Sum is not a number. Kind of is not a measurement. Precise measurements. Count every time you fail. Count how long it takes to actually move your changes into production. The only way you can actually build that type of a economical actually value by introducing a system if you know every single one of those factors. Because at the end of the day, if AVA is actually have an error rate on something that actually it takes us weeks to do, the compensating factor is a human labor that we just promised that we can actually move. So literally, the time money conversion, it exists because these two entities, AVA and humans, they are collaborating with each other. The less AVA does, the more human needs to actually compensate. And the fraction of penny that is cost, it's translated to the $20, $30, $40, depends on what actually skill set she's applying. That level of drastic penalty exists in this equilibrium that you're creating. So not knowing what the impact is to the level of precision that is needed, it has major flaws for applications or for the industry or the use case that we were trying to achieve. Code is not wine. It doesn't get better if it sits. Gotta move it. Gotta move it. Scaling is the biggest problem of the software engineering that you have. Things that they're sitting around, that they're not performing a task, and you have some perceived notion and assumption of what this thing does. Measure that and move it. Move it. For us matters because I just mentioned is we do not move the trained algorithm into production in 100 customer accounts that we have. Every minute that the operator is compensating is going to cost us. We talked about multiple AWS accounts and how do we actually make sure that we don't have scaling factor. Aggressively get rid of your infrastructure. There is no dev account for us. We can, in 5 minutes, decide to stand up an AWS account and do all of our development in that account. We get rid of it. We can switch the customer account. The only thing that we have to actually move is their persistent data. And do that on a regular basis. IT assets, they're not pets that you name them. That you build a relationship with them, that you feel good by actually having them around. These are tangible things, intangible things that you can get rid of and move. Get rid of your AWS account that you're actually doing your testing, create a new one. See how long does it take for you to be able to actually stand up the environments and do exactly. For every minute that you can do that immediately, there is one fundamental flaw in the architecture that you have. So what we've done today, we talked about a big industry problem, and our this goal, a big goal that we put forward to be able to solve that problem. We talked about the principles that we held on really, really tight, despite all the discouragement we got based on the set of numbers that we got at the beginning of our actually process, and eventually got over the hump, and we got the result that we wanted. And we talked about the flaws and the issues that ultimately became painful for us to get rid of. Our goal is to continue training Ava and be able to actually increase her skill set by creating a network effect in how we participate in that supply chain. We talked about 10 million loans being originated, probably 15 million applications being submitted. And if Ava be able to perform the first task, and she is in the flow of that transaction, we can introduce additional skills to be performed on the same transaction. And as a result of that, it creates a compounding factor and ultimately create a totally new paradigm of offering Ava skills in an industry that the adoption of actually technology, it's measured by years. Not months, not weeks, not days, not minutes, years. And the principles that we put in place, Ava has the ability to introduce her skills in those organizations, and with the right performance, she can actually perform bigger and bigger role in each of those organizations. With that, I would move to the questions. And again, thank you for your participation. And hopefully some of the stuff that we talked about, it was useful. But questions? Any questions? Yeah? Perfect. Thank you very much.